let's go over this one from yesterday then. I'm looking at this. What was our diameter? 30 millimeters. And what was this length across here? 80. So this one's relatively straightforward. From our center, of course, we've got right angles there and there. Those are each 15 millimeters. We got right angle there. We know these two figures, this and this, have to be equal. And I said this was centered, so this and this have to be equal. So we've got 40 and 40 and 40 and 40. So now we can cut them like that because we know from our rules of circles that if we have two tangents that intersect outside the circle, first of all, we use that the length of the tangents has to be equal from the point of tangency to the point of intersection. We also know that if we go from that point of intersection to the center of the circle, we get two equal triangles. So all four of those triangles are equal, are identical, congruent. So with that now, I can find this angle. That angle, actually what I'm more concerned with is this angle, aren't I? This angle here would be the inverse tangent of the opposite side, which would be 40, over the adjacent side, which would be the 15, the radius, which will give us an angle of 69.44 degrees. So that's that angle. Now I'm going to multiply by 4 because there's 1, 2, 3, 4 of them. It's 277.78. And I'm going to subtract that from 360, giving us 82.22 is this angle. Now I have enough information to find the area of this thing. To find its area, I have shape 1, which is a 40 by 15 triangle. So it's 40 by 15 divided by 2, because it's a triangle, times 4 because there's 1, 2, 3, 4 of them, which is going to be what? 1,200 square millimeters. Part 2 is the sector of a circle. So we've got the circle, which will be pi times 15 squared, and then times the 82.22 degrees over 360. So 3.14 times 15 squared times 82.22 divided by 360. 161.36 we're going to go. Which is going to give us a total of 1,361.36 millimeters squared. Anybody get that? Are really close to it? 1351.4464. Close enough. You used the pi key. Yep. That's good enough. Any questions on that? So if that were to pop up on a quiz, say tomorrow or Thursday. Possibly okay? This is one that really the trig isn't that hard. It's just a matter of seeing, first of all, remembering all your rules of circles and tangents and all the different things that have to be equal. Once you see what all is equal, it's not that hard of a problem. So, the next type of problem we're going to tackle this is an isosceles wedge with a 2:3 aspect ratio and 84 millimeters across here. This is perpendicular. This is a vertical, even though I'm not drawing it real well. And then this here is an arc of a circle, the 10 millimeter radius. This piece up here is a 1 in 6 aspect ratio. I want to know the length of this straight piece here, the length of this straight piece here, so those two lengths, and I want to find total area. In fact, I'm going to change these numbers up. I use the same numbers that are on your worksheet for today. I'm going to change it up a little. I want to make this a 3 to 4, this a 1 to 5. We're going to make this 120, and we're going to make this 20 millimeters. Make you guys work a little bit for your homework. So the first thing I want to do is I want to find this angle down here. This angle is going to be from that slope ratio. Realistically, what this is a triangle that looks like this, 3 to 4. Oops, other way around. 3 to 4. So this angle here is really this angle here. And that angle is going to be the inverse tangent of the vertical. Yes. Yeah, they're actually straight lines. So it's the inverse tangent of 4 over 3. Yeah, x and y goes to where the arc starts. It's the straight portion of the line is what I'm looking for. Yeah. So second tangent, 4 divided by 3. 53.13 degrees. Now what that means over here, since that's also 53.13 degrees, it means this one here is 36.87 degrees. Which means this here, by the way, 73.74 degrees. How did I get that? Perfect. 180 minus 53.13 twice, yes. Which means I can find this angle here. Now, of course, we know these are going to be right angles there. But we don't know where the center of this circle is for the 20 millimeters. But we can find this angle here because we know the angle up here to the horizontal is going to be from the 1 in 5 slope. So that angle is going to be the inverse tangent of 1 over 5. So 11.31 degrees. So that means if I cut this in half, this is going to be 36.87. Now, that is a full right angle there. So I take 90 degrees minus 36.87 and minus 11.31, which is going to give us what? 41.82. Somebody help me out there. Get close, Richard. Okay, what I'm looking at is this right here, right? What I've done is this. I've taken, here's where the lines actually are, right? I cut this angle in half, the 73.74 in half, to get 36.87 here. This is going to make a right angle because this is vertical, this is horizontal. So I put in the vertical in here, cut that angle in half. So that's where the 36.87 comes from. This here is actually outside up here, right in here. And that's just from the slope. The 1 in 5 slope gives me the 11.31 degrees. So it's these three angles here, here, and here that add up to 90. So that's why I took 90 and subtracted them to get the 41.82. Well, it's a way of looking at it. So now what I have, if this, what's that?
Why don't you just keep it where it's at the right angle and subtract the 73.74?
It isn't a right angle there. If you add that up, that does not come out to be 90 degrees.
Oh, I see. Not moving it here.
No, I actually created a right angle by putting in a vertical and horizontal. And it just happened in this case I could find all the angles but one from the vertical and horizontal. Now I'm going to focus in on this little section right here. I know, of course, this is 20 and this is 20. And I know these are right angles. What I'm going to do is this. I'm going to extend these out so that they meet. Why am I going to do that? Well, because I know this angle here is 11.31 degrees. I found that from the slope. So if I do this angle here, that's going to be a right angle, obviously vertical to horizontal. This angle here is going to be 78.69 degrees, which makes this angle in here 101.31 degrees, which makes this angle in here 78.69 degrees. Because I've got 90, 90, to 101.31, those have to add up to 360 because it's a four-sided figure. Now this angle out here really doesn't exist, but I had to draw it in so I could find this angle in here. So that is this angle in here is a 78 point, was it 61? 69 degrees. So what is all this junk going to do for me? Who knows, right? Well, what it can do for me is this. I can draw in a triangle here. Now that I know that, now I'm going to look at this triangle right here. This is a right triangle. This is 78.69 degrees, and this is 20. Don't know this length, do I? Because it doesn't go all the way through the radius. But I can find those lengths. This side over here, I'll call this A and this B. Sine of 78.69 equals B over 20. So I'll put this over 1 and I'll cross multiply and divide. So B is going to be found by taking 20 times the sine of 78.61. 19.606. A here would be cosine. So the cosine of 78.69 equals A over 20. So put this over 1 and I'll cross multiply and divide to get A. So A is going to be 20 times the cosine of 78.69. 3.922 millimeters. How does this help us all? Well, what this does, if this is 3.922, that means this is 16.078, right? Does that make sense? Because that was a 20 millimeter radius. So what that means is if I go up here, if I drop from this point straight down, this is 16.078 millimeters. If I drop this straight down, that would have been 60, right? Half of the 120, which makes this here 60 minus 16, or 43.922 millimeters. See where that came from? How does that help us? Because now I can look at this triangle here, and I can get a height. So I've got the length, the base of it. I can find the height. This is going to be the same as this angle up here was. That's the 11.31 degrees, right? 11.31. I just found out that's 43.922 down here. I can get the height of it right here. This tangent of 11.31 degrees equals, we'll call that h, 43.922. Put that over 1 and I'll cross multiply and divide. 43.922 times tangent of 11.31. 8.784. So now I can find this. This is going to be the square root of 8.784 squared plus 43.922 squared. Could have also used a cosine in this with the angle, but I've got it just to use the Pythagorean theorem. So second square root, second answer squared plus 43.922 squared equals 44.792. So that is x right there. Next, find y. Y is actually already found for us. First of all, I can find this overall height here. How? Well, out of the 120, half that would make this 60, right? And this is a 3 to 4 slope, right? So if I call this P or whatever I want to call it, 4 is the vertical, 3 is the horizontal, P is the vertical, 60 is the horizontal. Cross multiply and divide, P is 80 millimeters. Make sense? So P from here to here is 80 millimeters. But I just found out that from here to here was 8.784 millimeters. And I calculated earlier that the height of this triangle here was 19.606. So I'm going to subtract that from 80. So 80 minus 19.606 is 60.394 minus the 8.784 makes 51.610 millimeters per y. What do you think? Did we just run the tank empty for the day? I'm thinking maybe I should give you the worksheet now. Let's do that.